We'll get started in just a moment. Stop the alarm. And our rainy day jazz coffee house background music. All right, I gotta silence myself or it will make me crazy. Participants. Now I can't hear myself? Almost. What the heck? Better? Better. Okay. Hello, welcome to class. So here we are chugging through our last days, which is always amazing to me how quickly that happens in the semester. So today, any questions you have from chapters 8 and 9, I'm seeing a few populate in the chat. Honestly, truly, they are. You know, go ahead and ask any questions you have. You can private chat or chat so everybody sees to go over some of the homework questions. And then I will be with you here on Zoom while you take the quiz on chapters 8 and 9 material. They're a little bit different from each other, so it's not a natural pairing, but want to have a quiz on those before we're done with our semester. As you head into what I hope is a happy and delightful weekend, and goodness, like my daughter is she's a K-8 teacher, and so has this week off. And my wife and I have this weird teaching schedule where I teach on Wednesday and Friday, and she teaches on Tuesday and Thursday. So we've been alternating days doing something fun with our daughter. And so on Tuesday this week, my daughter and I decided to go for a walk around Lynch Park in Beverly, and then leave there and go to the Willows in Salem and do a direct comparison of the two parks. And of course, the Willows is better. But we walked around both of those parks, and it was a warm, beautiful, hot-ish day. It was all lovely. And then on Thursday, which I guess was yesterday this week, I had a meeting, and somebody at the meeting said she heard a rumor that George Clooney was down in Forest River Park filming a movie scene. I don't know if he was or wasn't, but my daughter and I later that day went for a walk down to Forest River Park, and there was snow falling out of the sky. And so we went from a warm, beautiful, sunny day on Tuesday to actual snow falling out of the sky on us yesterday. So, and then in the middle, they went to Audubon Society to look at birds, which is a cool thing, I guess, but you know, they're all just birds to me, so whatever. Anyways, that was our weird week. So we're gonna move into quiz questions. I gotta get rid of one thing and open up another thing. How do I get rid of this? I click on it, and then it becomes smaller. Go away. And sharing is paused. So I'll new share our Canvas page. We are finishing strong. We are here. We had our last normal lecture day. Today we have the quiz. Oh, I was starting to say, have a wonderful weekend, but as you enjoy your weekend and start next week, look at the practice exam, look at the chapter 10 homework, and come prepared with any questions you have on all of that stuff. I've communicated with Professor Logsdon. He is trying to finish up grading labs as much as he can. So hopefully you have submitted everything you have for him, and he will get those scores to me as soon as possible. So it is my hope that by, next Friday, when you take exam 2, you will see everything. You'll see your homework scores, and if you have any zeros on homeworks, you can redo it. You'll see your quiz scores with one of the lowest grades dropped. You'll see your lab scores, and once you're done with exam 2, you'll see where you stand on everything in the course to then be able to make a rational decision about how you want to proceed with the final exam. Okay. The question that I have gotten multiple times is number 7 from the chapter 9 homework. So I want to both answer that question and include a warning. All right, so there's 2 children. They're sitting on a seesaw that is balanced at the pivot point that is located at the center. We have child 1, we have child 2. I don't know where either child is relative to the pivot point. I'm given masses of the children. I don't know where either child is, but I do know that the total distance between them is 3 meters. So x1 and x2, the distance for child 1 and child 2, add up. X1 plus x2 equals 3 meters. That's the information that I've been given. If they are balanced, then the torque on the left-hand side equals the torque on the right-hand side. And torque is force times lever arm. Force is weight, mg. So m1g times x1, force times lever arm, on the left equals m2g times x2 on the right. Our lives become a little bit easier because g appears on both sides of the equation, so we can cancel it out. So m1 x1 equals m2 x2. We know m1 and m2, but we're still stuck with one equation with 2 unknowns in it. I don't know what x1 is, and I don't know what x2 is. Ultimately, I want to know what x1 is. I want to find the pivot point for the small child, or the distance from the pivot point for the small child, in order for this to be true. So I want to find x1, but I got nothing. I don't know what to do. But I have a whole second equation. If I want to find x1, this is weird, I'm going to solve this equation in terms of x2. x2 equals 3 minus x1. I'm just going to get rid of the units for now because that might confuse us needlessly. x2 equals 3 minus x1. x2, this value right here, x2, is 3 minus x1. So m1, I'm just going to fill in 20 times x1 equals 30 times 3 minus x1. Does that make sense what I just did? I just plugged in numbers for the masses, the numbers that were given in the problem without units because we're being lazy that way. X1 is just the distance from the pivot point for the smaller child. And then on the right-hand side of the equation, the mass of the heavier child. And then instead of just saying x2, I'm going to say 3 minus x1 because those 2 things are equivalent because I had a separate equation It's called using simultaneous equations to solve for, multivariables. So here's where it's just some math. 20 times x1 equals 30 times 3 is 90, minus 30 times x1 is 30x1. Now I add 30x1 to both sides of the equation, and I get 50x1 equals 90. So x1 equals 90 divided by 50. That's got to be some kind of number. 90 divided by 50 is 1.8. So the distance from the pivot point for the smaller child is 1.8 meters. And therefore, the distance from the pivot point for the larger child is 1.2 because they add up to be a total of 3 meters. Now, all of this was predicated on the torque to the left equaling the torque to the right, which was M1 Gx1 equaled M2 Gx2. So another version of this same question that could be on your quiz momentarily would be if I just said, okay, 20 and 30 kilogram child, but the smaller child is 1.5 meters from the pivot point. Then it's just so much easier because it would be x2 equals m1 x1. So 20 times 1.5 divided by the mass of the heavier child, 30. And this question, 20 times 1.5 divided by 30 would be 1 meter. It'd just be a simpler question if I told you the distance specifically and directly rather than had it hidden in a simultaneous equation. So brace yourself for an easier question on the quiz than there was on the homework. I'm trying to be your friend. Maybe I'm not trying to be your friend. I'm trying to be nice. I don't want to be your enemy. I'm just, let's be reasonable here. Okay, clear all drawings, close that. Okay. So there are questions on today's quiz from both chapter 9. Chapter 9 had a really straightforward question on torque, since torque equals force times lever arm. And number 1 here gave us a force and a lever arm. It was just that simple. And then number 2 or number 7, the second question, was a little more complex. The other chapter covered on this quiz is chapter 8. And the chapter 8 homework is not as difficult as it looks here, but has to do with momentum and kinetic energy and the whole idea of conservation of momentum, and that impulse, I need to annotate again, come on. Impulse, which was J, equals F delta T, force times time. So if we could figure out what the change in something is, we could go ahead and, figure out the time. Time equals impulse divided by force, or, changing kinetic energy or whatever. Okay. Yeah. So conservation of momentum and that stuff. Are there questions on this homework that people want to go over before the quiz? You know, some things are just as straightforward as they seem. Momentum is the product of mass times velocity. So here we have an elephant, 2,000 kilograms, traveling at 7.5 meters per second. So the momentum is 2,000 times 7.5. Yeah. So any other questions on the homework before I say go ahead and take the quiz, unless you already are? Go ahead and take the quiz and I will monitor chat. Number 32, please, I see. So this was what? My greatest ever stop motion video. I hope you watched it and loved it.
Yeah, that was hilarious.
It was hilarious. And then I stopped doing it because, man, it takes so long to make a stop motion video. I have so much respect for people that do that.
You have quite a talent for it.
So we have two skaters, one who is moving and one who is not. And so the one who is moving is carrying all the momentum into the situation. The initial momentum of the whole thing, both of them together, equals the final momentum of both of them together. But the initial momentum is just the one who's moving. So it's one person who's moving at 4 meters per second. So M1 V1 initial plus M2 V2 initial, which is 0, equals M1 plus M2, they stick together, times some final velocity. So this whole thing becomes rather simple if you do it algebraically. The final velocity equals M1 V1 initial divided by the total mass, both of them together, M1 plus M2. So M1, 60 kilograms in this case, times a velocity of 4 meters per second, divided by 60 plus 75 must be 135 kilograms. So 60 times 4 is 240. I could have done that in my head if I was, thinking. Divided by 135 is 1.78 meters per second. When the fast skater who is light jumps into the air and is caught by the heavier skater, they will move off together at a slower combined velocity. Or maybe it's a dolphin and a Polly Pocket doll that belonged to my daughter when she was young, and now she's like 25 or something weird. Okay. Any other questions before the quiz?
I have a question.
Yeah.
So the symbol for momentum is P.
Correct.
Right?
Lowercase p.
Lowercase p. And then how is that different from impulse?
So impulse is going to be the change in momentum for something. So impulse is always change in momentum, delta p, and it's the product of average force times time. Whereas when we're talking about just momentum, we would say the momentum that any object has is the product of its mass times its velocity.
Thank you.
Sure. Any other questions? All right. If you scroll down on our Canvas page just a little bit, Friday, April 23rd, last quiz day, quiz on chapters 8 and 9. I will open it up here just because people will sometimes ask questions that they want answers to, and I will be scrolling around to look for those. I don't think we have any images to get messed up with, so go ahead, take the quiz, good luck, have fun, and I will be here on chat to answer questions as you have them.
You said momentum was P, right?
Correct.
Okay, thank you.
Yep.
Have a good one.